Layered Insights. This is a 3D printing podcast. I'm Alex. This is Matt. So what's going on, Matt?
It's actually a quiet time in the house right now. No 3D printers are running right now.
You just finished like a big project, right?
Yeah, I just finished a big order, so off to more designing and then printing again.
The process.
Yeah.
Yep. That's manufacturing, which is what we're doing here, even though it's like its own thing, 3D printing, right? It's like you don't think about like injection molding machines
Yeah.
or like anything like that when you think of 3D printer. You think like I would think most people think like trinkets or like a lot of stuff that's coming off of bamboo printers now.
Yeah, when I think the majority of stuff we're printing is has more, it's not trinkets. They actually have real world applications and people are using them for a variety of different things.
Absolutely, yeah. And I think we're like the black magic of the 3D printing world. Actual real end use parts
The
on
the
a 3D
functional
printer.
prints.
Yeah. Yeah. And that's where we're going to talk about today is actually going scaling from prototyping a part to like a production part. And on the 3D printer, it's a great prototyper. Probably one of the cheapest prototyping anything
Yeah,
machine.
absolutely.
Yeah, that's out there. But like you can't just use a prototype machine to make an end use part. There's a whole bunch of other things that you got to do.
There's a whole, yeah, I mean, when I do it, it's usually a whole bunch of stages,
hmm Let's get
right?
into that. Let's talk about
Yeah.
your process.
So I'd say, you're designing your part, you print, I don't know, let's say 10 prototypes, right? Uh, Depending how lucky you are. Um,
Yeah.
and then you get to the part that, the customer likes, right?
hmm
They prove, yes, this is the part I need and want. It functions how it should. It looks relatively how it should,
hmm
right? But then, oh, they want 300 of them, right?
Right.
So you're not going to use that same print file, maybe not even necessarily the same model as you just did for the prototyping.
Mhm.
So hopefully you design for additive manufacturing while you're designing and prototyping. But even then, there might be a couple of things that you discover when printing the prototype that you're like, oh, this could be better when I'm trying to produce, hundreds of them at the same time, or
Yeah.
I found this problem. And that's even going into, you're not going to use necessarily the same settings. Maybe you want it a little bit stronger for the real thing or to look aesthetically better. So then you're changing the settings, and sometimes you want, to use less material, cut down on the cost and time and the amount of
Yep.
material. And then, I mean, we can even go into like, do you print one on a build plate at a time, or do you print,
Mhm.
10 on a build plate at a time?
Yep.
Do you use, do you try to support the part as much as possible,
Mhm.
but then post-processing will be a pain? Or do you maybe cut up the part and assemble it later so
Yeah.
that you have less
Like
post-processing in terms of support?
yeah, 100%. And there's like so many different ways that you can go about it. And like each project is its own thing. Like I there's a project I was working on for something in my house that I did in one try. And that's
Mhm.
like that's what everyone hopes for is like
Oh
your
yeah.
prototype is also your end use thing, but I had the luxury of starting completely from scratch. So I didn't have,
Hmm.
design constraints or I think we work with I think companies a lot of the time or people starting trying to make a product that could
Yes.
become something. So yeah, like the prototype can be super cheap and fast, but
Hmm.
you do want that for the final part that you're printing, like the
Yeah.
end use, the final product. But
I would also say print time and material usage and stuff also doesn't matter in the prototype, right? You're
yes,
just printing one to prove the concept.
yep, yep. I'm doing that right now with a job I have with someone who's we're basically reconstructing or reproducing a what's the word I should like a an architectural icon in the town that this guy puts on events for. And so we're trying to make that into a like an insert slash phone stand.
Yep.
So they're like the prototype, uh, my prototype for that one, I printed out some of it has brick. So I had a filament that has that brick color, but I didn't want to go the full extreme. I want to see what I could get away with just the color and a few bricks
Hmm.
instead of completely one to one, like recreating the brick scheme because
Yeah.
I don't know if the nozzle is going to be able to handle that, but I think for me, for my thought process with something like that, it's run some prototypes quick. That's not even the final part, just certain
Hmm.
features that you're interested in.
Oh yeah. Even
And
just for fit and function,
mhm,
like cut up your model in different parts just to make sure this one part of it fits or functions like it should too.
yeah,
Especially if it's a like a big part, all
mhm,
that print hours, or what if you get a print failure? All
yes.
that prototyping time was wasted just when you're trying to see if one feature worked.
Yeah, yeah, and that kind of goes back to like your point about the putting too many parts on a bed, or like if you're trying to mass produce, you start
Hmm.
adding more than one part. There is a line where like if I print more than these, just one of those parts kills the entire print. And with the print time you're talking about, some of
Yeah.
the prototypes are going to be either durable, so they got to be strong, which means they're going to be bigger, or they have a lot of different colored aspects to them. So those things add time. And so
Yes.
if you're in for a 24 to 48-hour prototype, which isn't even the worst case scenario for print time or prototype, like
Yeah, yeah.
you could go a whole day or two without having anything to show for your work. And so
Hmm.
that's I think where we find the magic in what can we get away with and still learn in the process of it.
Yeah. And some of the like if you are printing a bunch on the print bed nowadays, some of the printers are good that it might catch a failure and you can skip that one part.
True.
And maybe you can salvage, the rest out on the build plate.
Is
But
that
you're
something
still,
on like a bamboo?
yeah,
Right.
the bamboos have it.
Hmm.
I think some of the Creality and some of the other ones have it too. It's nice because you'll do, it will do the spaghetti detection, so it will see the fail print.
Hmm.
Actually, on the Prusa's you can do it too now. At least on the XL, you can select part
Right.
by file name and skip that one if you see a failure. So
Wow.
that helps a lot when you're producing a lot of them because, if you're printing thin, tall parts, you could also only just have one get knocked over,
Yep. Happens all the time.
right? And then what? If you don't, if the printer doesn't catch it or you don't catch it, maybe you can salvage some of the parts. But if you try and print a bunch of them, it's a long print. You wasted a lot of time and a lot of material. So we'll probably do a topic on this later, but how dumb the printers are right
Yes.
now, right?
They really are when you think about what they could do.
Yes.
Yeah. It made me think of a part that had failed, and I'm sure everyone has a story where you print a really tall part, maybe more than one of them, but let's say it fails at a certain layer. You've got half of this part is beautiful, and then you're just sitting there going, what layer was that on? Instead of
Yeah.
actually like counting the layers, because sometimes there's just no way you'd figure it out. Maybe you
Yeah.
get a feature that's near that, so you kind of like estimate. That's part of troubleshooting and like salvaging a job that fails, like new users of 3D printing run up against and deal with. And that's when they learn that situation, but it's not something anyone ever expects they'd have to do when they get a
Yeah.
printer.
I think, like you said, with the layer height too, because if you're printing a bunch of parts and then you do have some type of failure, like, okay, we're at this layer height, what part of the tool path, what part of the settings caused that error? Was it
Yeah.
something weird with supports, material buildup? Am I not doing a Z hop? You should definitely do Z hops when you're printing multiple parts,
Mhm.
when you're going between the parts. So it's like,
And what's the reason for that?
yeah, so well, either it'll lift the nozzle or drop the bed depending on your printer, but
Right.
you're going between your parts, you're making sure if you do have any material sticking up, the nozzle won't slam into a part.
It's gonna print on that one part, and then
Hmm.
without the Z hop where it the nozzle goes up or the bed goes down,
Yeah.
when it moves away, it's not gonna drag the part, which might have like a really thin or delicate
Yeah.
adhesion.
And even unless you tell it in the settings, the nozzle will just blast through any parts. Unless you
Mm,
go into the settings and say, hey, when you're traveling around, not printing, make sure you go around the part. So there are settings where you can say,
mm,
hey, don't cross other models when you're traveling.
yeah.
So there's different settings like that when you are printing multiple parts that you might have to consider, or even just the build up material or how the nozzle is getting cleaned if you are doing filament swaps or
Yep.
different things. 'Cause, like PETG is a big one where the material can build up on the nozzle.
Hmm.
Even if you're just printing multiple parts and not swapping or anything,
Yeah.
you can still and and your flow is right, you can still have a little bit of material build up on the nozzle, which can sometimes become a problem further in the print. So it's learning and knowing what's going to cause the problems and then adjusting it as much as you can in the settings so
Yeah.
you can print as much of the same file over and over again without having failures, without wasting time, without wasting material.
Right. Well, that's a great, I love that segue because I think we could do this. We wrote down a bunch of ideas for like what it is to go from scaling prototype to scaling production. For each one of these, we should talk about what's acceptable for a prototype and what's acceptable for
Oh, yeah.
production.
Hmm.
Um, because I think there's a lot that we could just pull from there. So like first of all, like a prototyping part, like what you were describing, that's a perfectly acceptable thing with the nozzle stuff and batch printing. It's
Yeah.
almost good to prototype the batch printing before you
Oh,
commit fully to the production because like
absolutely.
that's acceptable in the prototyping phase to hash out.
If you can with a client or if you are in your own company doing this, it's good to, print maybe 10 or 20 models of the batch of your batch printing file
Yeah,
and then bring it to your client or the rest of the engineering team who's going to be using it and say, hey, can you test these? Is this acceptable? Get the okay from the people that are getting the parts. And if
right.
they get the okay, like run, run with it and keep printing as much as you can. But yeah, it is good to get the approval of the prototype and then get the approval of like initial batch print, which with settings that you think are good and the parts are looking good. Just to, because even you might go and change some settings to get the batch printing working well and time efficient and less supports or whatever it is, less post-processing. You might bring the client and
Yeah,
piece isn't fitting right, or
right.
it doesn't quite have the same aesthetic you wanted or something. So
Mhm.
you got to keep that communication
Totally.
between your clients or the other team open through the entire process.
Yeah. Yeah. 100%. 100%. Um, so let's talk. So like let's say you get a model from a customer and
Mhm.
your task is like we're gonna prototype this, but we'd like to eventually produce a lot of these.
Yeah.
How would you approach with the model, the prototyping phase and then the production phase and kind of like tie in like design for manufacturing that's also in there?
Yeah. So at least for me, a lot of the time I'm actually designing the parts myself.
Mm,
But even if customer comes to me with a part that I could edit, I usually do look at it from a design additive manufacturing first and say, hey, can we, I'll probably give a list of suggestions saying, hey, can we do this? Can we do that?
yeah.
To not only make it a better part, have it stronger for 3D printing, but make it easier to print,
Mhm.
less post-processing, less supports, all that stuff. So usually I'll make some suggestions. If it's good, I'll edit it and then I'll prototype it. So like
Mm,
if it's a big part or different things, I might not do a lot of outside layers as much as I would for the real part or as much
right.
infill. Probably use less material, try to print it as fast as possible for them. But at the same time, it's kind of like sometimes I'll add more time to the print because I don't necessarily care about the print time, but I want to make sure the part comes out well.
Right.
So maybe I will be more on the conservative side with the supports or the settings and stuff, not tune it in as finely as possible because I don't want to spend time printing a bunch of stuff and tuning it in and have it turns out it's not what the customer wanted, right? So
Right.
you tune in
Yes.
and you scrape more time and get it more perfect when
Hmm.
you're in the batch and manufacturing phase.
Yeah. Yeah, and it's interesting because I think everyone has their own approach, but like the things you're talking about are pretty general, like good things to consider.
Yeah.
I do find, and this just might be the prototypes that I work with, it actually ends up some of the time being cheaper just to print out something early on in the prototype
Hmm.
phase, just because I learned so much about what I need for the production side of things or
Yes.
seeing that part print or like
Hmm.
seeing how the part quality is and knowing, you know what, the way we're doing that isn't gonna work. Like I think this James Webb model is like a perfect example of that process of like I haven't seen like a really high quality version of this 3D
Yeah.
printed, but if I'm gonna make these to sell these online, what do I have to figure out? And this was a very challenging version of that because a lot of it had to be in the printing stage because I had to,
Yeah.
in this case, print the whole thing in one piece in multicolor.
Hmm.
So I did spend a lot of time and filament doing that. And I was testing how good is my hardware to
Yeah,
accomplish,
yeah.
which
That's
isn't
another
usually a
aspect
problem that most people
of
like try to do. But I like the pain of the process, so it is what it is. It's just when you win in that kind of a scenario, you can really unlock. And I know that's not most people's scenarios here. Uh,
yeah, yeah. Well, I think the advantage of 3D printing because you can just design it, print it so fast, right?
yeah,
I try to get even if it's, even if the design's not fully done or something, I try to get it printed as soon as possible so the client can just have ideas. Is this right? Is
yeah,
this what we're trying to get here?
yes,
And if it's not, we can, quickly go back to the design board and iterate quickly. But I think it's a lot of people haven't used 3D printing technology.
yeah,
So it's nice to get them apart and say, right, mass manufacturing is going to look better, but this is kind of how it's going to end up looking. And they have a general idea of what to expect
yeah,
out of the process, which is really good. Because then if it's not what they want, it's, maybe the 3D printing is not the right thing or you have to change something, but at least they know what to expect
right.
and how we might want to move forward. So we're not wasting time designing when, this isn't exactly what they wanted and stuff.
Totally, yeah. And that's the balance of having a customer and, providing a service for them. It's just like you're talking about something that's very important that I think a good amount of people starting off in 3D printing struggle with, which is that when you're hired to 3D print something, the more time you can spend on focusing on what they want instead of maybe
Hmm.
how you would do it,
Yeah.
because then your job, once you know what they want, is how to do it.
Hmm.
And if you set those expectations up ahead of time, the whole process is so much better for everybody involved. Yeah.
Yeah, definitely.
Let's see here. So I was trying you brought up so many good things in that. Just like
Yeah.
this difference between prototypes and actual production. So we could, settings we talked about a little bit already. Filament. I think for me,
Oh yeah.
starting with PLA or something very
Hmm.
cheap and something you can print fast is
Yes.
perfectly acceptable. Because there's
100%.
we live in a world of multicolor parts, like this, but like not every prototype needs to be multicolored. In fact, you probably shouldn't color the prototype like at all because
No. Yeah.
you're getting the fit and the form and how well do those settings work. It's almost like getting like a temperature, like a reading on like how close are we to actually
Yeah,
print
yeah.
that
And
scale.
you're initially focusing on the design.
Yes.
So like definitely print with PLA first, especially if, maybe it is a real engineering part, so you have to use something that's harder to print, like
Right.
polycarbonate or expensive, right?
At the expense, yes.
Right. Or even, maybe you're even doing a peak and all temp part or something crazy, but it's
Hmm.
like, let's get the general design and fit and kind of function, how it works and looks
Hmm.
out of the way and say, yes, this is what we want. And then you can kind of tackle, okay, how am I gonna print this in this hardware engineering material? Because some of them are more challenging to print. You have to think more about warping
Hmm.
and different things. But if some of the design, you're printing 5 prototypes, and you don't want to print that in some of these materials because it costs you a lot.
Oh yeah. Hmm.
So you're talking about maybe the last few prototypes are in the real material because then they can take it home and actually, maybe they're using it with chemicals, they're using it with high temperature, different things, and then, they can functionally test it more in that aspect. But
Yeah.
usually, as long as you know a material is going to function how you need it for their environment, you focus on the design first, and then you say, hey, just use some cheap PLA, right?
Totally. Totally. Yeah. And I think there's a whole because if it, the other thing I think that people run into is when it's not a brand new part that hasn't been made before and you're prototyping, maybe reproducing a part, but using
Yep.
3D printing, a lot of the expectations are like an injection molded part or something that
Yes.
was machined. So that gets even more tricky because the prototype may cause the customer who's like brand new to 3D printing to kind of back off and go, oh, there's like when you make the prototype, they're like, that's not what I was looking for at
Yeah,
all.
exactly.
And that becomes a really interesting dynamic when you're working with somebody on how to get them past the prototype and to like, you hit the nail on the head. Like you, it's the expense of the whole thing. It's like
Yeah.
I'm making this prototype, but in order for us to move through the process, let's do this quick and cheap because
Hmm.
it's going to cost you more if we do it in something else.
Yeah,
And
and
go ahead.
even if the customer's used to the machine materials or
Mhm.
injection molding, right? And you give them the part, then you can kind of do the back and forth with them saying, what about how it's manufactured do you not like here?
Mhm.
Because, some of the things that people don't like about 3D printing can be actually somewhat adjusted in the
Sure.
printing process or post-processing. So it's like
Yeah.
uh, you don't completely outrule the technology because there is ways around it to make sure it fits what your customer is expecting out of the part.
Right. No, totally. Totally. And I think the cool thing about when you go through that process, especially when it's the first time this model is being 3D printed, like it's not, and no 3D printing process or even manufacturing process is perfect. But I think
Yeah.
that's an expectation that people have.
Yes.
And one of the important things that I always like doing, unless it's prohibitive cost and time wise, is to print a part because you're also learning how the machine is going to handle this, that you're going to
Hmm.
eventually go to production with.
Yeah.
So there's so many subtle things like walls being thicker, holes being smaller, and just like the overall dimensions of the part, you're getting a gauge on like the good thing is you can adjust that afterwards. Like maybe you
Yes.
designed it as 3 inches, but it comes out as 2.9.
Hmm.
Well, you can then make the model zero point 0.1 more, and then you print it, and then you check it again, and then within two prototypes, you can get that perfect essentially almost every
Yeah.
single time.
And the iterative process for 3D printing is so much faster than the subtractive processes of manufacturing. So it's like
Sure.
it's when you get to a decent prototype, I sometimes just encourage my customer put put as much through its pace as possible. Try
Yeah,
to break it.
yeah,
If
yeah,
it doesn't hold up to how you think it should, there's tons of stuff we can do to make it stronger.
yeah. Yeah, and the ones that can document it failing and give us pictures and get as involved as possible in that gives us so much information to work off of.
Yes. Uh-huh.
And then the cool thing is once you're in the 3D printed thing, and this is more your expertise, then you apply the material science on it, right? You can
Yeah.
go from
Uh-huh.
a PLA to a peak, and the part becomes almost indestructible in most uses of the part, It's like it's really something. But
Yeah,
please go off on it because
yeah, even the right, making sure you pick the right material for the application. I've had
yes.
customers work with other companies and they're printing with the wrong orientation or they're printing with the wrong material for the environment. So it's
Mm,
like, and then, even, there's subtle intricacies between some of the different materials where if you want more strength or more layer adhesion on this, there's some tricks that
mm,
either, dehydration or doing thicker line widths or different things you can actually do
yeah.
to utilize the material more and get more out of it.
Hmm.
But
Surface finish too, right?
so
Like
yeah, oh yeah, so that's a
yeah.
great point. Surface finish too. So even like right, some stuff you want texture. So like even using the fuzzy setting in some of these
Mm,
slicers helps, hide some of the layer lines, but also uh gives a different type of part to a customer. And
true.
but yeah, it's when you go into the more engineering, even like just polycarbonate or nylon and stuff like that, ASA, they can be a completely different wheelhouse sometimes than PLA.
Yes.
Speed you print it, how you print it, and they'll have some, little tricks on how you can how you can improve the process, especially for if you're slicing specifically for that part. There's different things you can tweak in the slicer to give
Mm,
you a better outcome in a stronger part too.
yeah. No, absolutely. I think we both worked on the engineering side of things. So there's kind of choices that we're kind of met with all the time. So there's a lot of things that are just kind of like, oh yeah, you do this, you do this. But with I think some of our work, especially nowadays, a lot of it's more cosmetic or uber specific to a very specific material type. Like,
Yeah.
could you talk about just talk about some of the basic materials and like what they might be good for and trade-offs? Like start with PLA and
Yeah, yeah.
just roll with
So
it.
PLA is definitely like the easiest to print. It's gonna be good for quick prototypes. It's good for a lot of fidget stuff and aesthetic models, right?
Good for color,
Good
multicolors.
for oh yeah, great for color. Yeah.
Yeah.
So that's kind of the wheelhouse that's in.
What is it bad at?
It's well, it's actually pretty stiff for not
Yeah.
having any fibers or other things in it. It's actually a pretty stiff material, but in terms of higher engineering strength, you're not going to get that PLA.
It's gonna
It's
shatter.
got it's going to shatter. Yeah, it's very brittle. You're going to get it's not going to be able to stand a lot of heat. Has
Hmm.
less toughness or impact
Yep.
strength.
Not an outdoor material.
Non-outdoor. Oh yeah, it's gonna degrade in the sun. The color is gonna degrade. It's gonna
Yeah.
get more brittle.
Yep.
So I'd say like the next tier from that would probably be like a PET G.
Hmm.
Back in the day, it used to be, I'd say like an ABS,
Yep.
but a lot of people have turned away from ABS because of the warping, the printability, and the fumes.
Yeah.
And right now, PET G is a really good alternative and
Yeah.
replacement for that. So your PET G will be a little more UV resistant. It'll be better outdoors. It'll be a little bit better with the water. It can absorb a little bit of water.
Yep.
Um, so usually
I've definitely had to pre-dry while I'm printing, uh,
yeah, a lot of
especially translucent stuff. Um,
translucent stuff
but
is almost even even translucent PLA and translucent PET G, it's almost like a different plastic when you're
yeah,
printing it.
it's crazy. You
Yeah.
wouldn't think of that immediately.
Well, it's like you know, well, you think about materials to get the colors, to get some of the properties, to get some of your PLA Pro or your PETG Pro or different things, they're putting additives in it.
Right.
So like some of the lower grade plastics have more additives and less pure plastic. So there's that interesting trade-off and how the
Yep.
additives might affect in a good way or a bad way
Hmm.
the properties of the material. So PETG will be, a lot more of functional parts, parts that might see a little bit of abuse, parts that see more environment stuff.
Yeah. And that's
Um,
why it's so good to start with the PLA because it's such a well-used material. It's
yeah,
understood pretty well and it's cheap and you can print it fast. So, like, you don't have to deal with a lot of the problems you might have to deal with at the PETG or higher
yes,
because we don't know all the things about those materials yet. And once you get past PET-G, it starts to get where your prototyping time, if you choose to use that material first, is
yeah,
going to eat you apart because you're actually dealing with the material and
yeah,
not the prototype.
yeah. You're fighting the material versus fighting the design.
100%, yeah.
And you'd be unless you have unless the client has very specific work requirements, you can. I mean, PLA is pretty decent now. Like
Yeah.
you
And
can
there's
end
PLA plus, there's some extra strength and stuff
you
you can
can get
do
away
with it.
with using PLA for a lot of parts unless
Yep.
there's certain environmental conditions and working conditions.
Yeah.
From there, you got your ABS, your ASA, some of the stuff that's sometimes you'll use it. I probably move closer to more polycarbonate.
Mm,
You get a lot of strength for how cheap. It's not cheap, but
yeah.
you still get a lot of strength for the price. But you do need to take into consideration warping and different stuff.
Yeah,
Um,
polycarbonate, at least from my memory, I don't remember ever choosing it because of the potential fumes.
yeah,
But also I don't think printers at that time were even capable of it before the all metal hot ends or like some of the 250C on a 3D printer was like an expansion point of all the stuff you could.
yeah, yeah.
Yeah, that was an era for sure.
Yeah, and you need the enclosure in the
Yep.
right heated bed, especially for the polycarbonate. Even the
Yeah.
ASA and ABS, right?
Hmm.
You need a decent enclosure to keep it warm in there to prevent warping
Yeah.
and to get good decent layer adhesion.
Yep.
Yeah, then there's, a lot. What's really popular right now is nylon,
Hmm.
especially with fibers.
Yes.
But even nylon, it's actually a lot better than it used to be.
Oh
Nylon
man.
used to be a lot harder to print.
Hmm.
It was a lot. They even have some of the nylon builds even absorb less water, so you have to worry a little bit less about it absorbing too much water and not being
Yeah.
able to print with it well.
I remember this is like the Tallman material. Do you remember the
Yep.
Tallman? Yeah, alloy. Like that was
Hmm.
um a very interesting nylon, and there were a bunch of different ones that you could get for different types of things. I think I made a prototype of it was for my friend, like the bottom of the ski pole, that
Oh,
little
yeah.
part. I had made a replacement for him, and I used that nylon for that. But just like you said, it was a struggle, and like it was getting it to adhere on the bed and then to itself
Yes.
was always like a struggle, and it felt like anytime you opened up a bag of that stuff,
Yeah.
the best print you got was from the
Uh,
very beginning,
mhm.
and then you could never dry it out enough for it to get good. But now, especially the stuff with the fibers, it's really come a long way where it seems anecdotally, even though I've got a lot of time with these harder materials with fibers, it seems the fibers actually help against the problems of these materials.
And I mean, that's one of the reasons a lot of people are adding fibers to filaments right now. It is a little bit, of a craze and it's overblown, but it does help in certain ways. But it's not,
Yeah.
I think people think the part's going to be stronger than they actually are by adding fibers.
Yeah.
But yeah, I think the overall grade and how they're processing the nylon and making these filaments are much better than back in the day. Like
Good
normal
point.
people can kind of print the nylon now, and back in the day it was much more of a struggle. And
Yeah.
it's since the nylon can be pretty cheap now and easier to print, it's almost the next thing people print with besides PLA because it's almost the opposite of PLA because you get, nylon's not brittle. It's
Right.
going to take impacts. It's,
Gonna
you can slam
deform
it on the
before it's
ground and it's not
yeah.
going to break and stuff. So
Yeah.
that's kind of almost the next step people take in terms of material.
That's crazy. Now, are do you think those people are actually have a ventilation setup, or is it just kind of like is this hobbyist that you see this or
For
industrial?
nylon,
Yeah.
uh, no, I think it's people that have more of the enclosures and
Mm,
a little bit, maybe one step higher than
okay.
like your cheaper printers.
Yeah. Because I remember in
So
the early days when people were using ABS and PLA, there was a lot of people printing ABS in their homes.
yeah,
It was like, oh, no, get that stuff out of there. I mean, it smelled terrible, so it's not like you weren't aware of it, but
yeah, yeah,
boy, is it not good for you.
not good. Yeah, it
Yeah.
releases a lot more VOCs than a lot of the other printing plastics.
Hmm.
That and ASA too.
Yes, and that's why I never used ASA, even though I
Any,
think it'd be really good for like outdoor
yeah, it
environment.
is. That's the thing.
Yeah.
Anything with the styrene,
Mm.
that's what you're smelling and you're getting the
Oh,
byproducts of.
yikes.
Yeah.
Cool. Okay,
Yeah,
so
there's
nylon and
yeah.
and and fibers inside. That's kind of one stage.
Yeah, and then even well then for a complete type material, people are printing with TPU now a lot more too.
Yes, yes.
That's a fun one. I mean, it is, I'd say it's still, they're making it a lot more printable, but still a little bit of a challenge or different, I guess, compared
Mm.
to PLA or some of the other ones. And it's slower, but you can get, you know, for soft, semi-soft prints, it's cool material for a lot of different things.
Yeah, I'm seeing people do soft robotics with the more like
Soft
elastic ones.
robotics, yeah.
I thanks to you have this prototype here that we made in that TPU foam,
Oh
which is
yeah, the
super interesting.
Verisure, yeah.
Yeah, exactly.
Great cosplaying material.
It's really like amazing. Like it's just its rebound to its original shape. It feels like something I could buy, like a backpack, almost
Hmm.
like a fake leather.
Oh
Um,
yeah.
and but talk more about that and like how because it used to be that there was just kind of everyone would say there's different durometers or like different what's the word I'm looking for? Springiness or softness that you can
Yeah,
get.
softness.
Yeah, but it wasn't like it was available. Like there wasn't like a wide range of them available from every person. It was like this person's was harder than this person's, and this
Yeah, there
CPU
was
was like too bendy, so I couldn't do anything with it.
yeah, I mean a lot of the first ones was like mostly coming out of Ninja Flex, right?
Yes. Yep.
So like I think they're, a couple of their first ones were around the 90A durometer.
Hmm.
And then, they got much lower. I think the
Yeah, it went
Chinchilla,
lower first. Yeah.
but like uh, you could count as many as many on one hand as the printers that could print the Chinchilla. The
Right.
Chinchilla
Yes. Yeah.
was super hard to feed,
Yeah,
but
that's a major downside and struggle with TPU is your extruder might not be, or it might not
it
be able to
has to
handle
be
it, but
of a certain
also,
durometer to be able to push it through almost.
yeah,
And
exactly.
then people will come up with mods. So like there's less gaps within the extruder for the because that stuff will just
Because it's gonna,
escape
right, right.
and
Yeah.
find its way out. So like
Yeah.
I actually have a mod for the XL that tries to close the path as much as possible so that it
Wow,
can't escape.
that's cool.
So you're almost like limited to durometer for TPU
Mhm.
because you have to be able to push it through and feed it through the extruder. That's where like
You can't push a rope, as they say.
yeah, yeah, yeah.
Yeah.
So that's where kind of the well, and that, a lot of printers now are direct drive too, which helps with
Yes.
the TPU. But then that's where like the Verisure product comes in,
Mm,
right? You can actually get lower durometer depending on the temperature you're printing it.
right, right,
So you can kind of scale it and get lower durometer than you get with
right.
other materials.
Yeah, so up here I had like changed the temperature, so I believe this was pretty cold, so it's a lot harder. But
Yep.
then like here it was hotter and I've got, so much flexibility here that it's really something.
And the what I also like about the material is you can post process it with fire a little bit
Yeah, you were
and
telling me
get
about
a
that.
nice finish. It easily cleans up any stringiness. You can actually get almost a shininess
Mm.
to it afterwards. It's really interesting.
And
So
what's
that's
the action there? Is it
I think
there's an
it's
additive that's
almost
like that's not burning off. It's turning into gas as it's printing.
well, I think it also kind of because it's when you're printing that material, you're foaming it.
Right. And
So I
I think
think
the
you're
foaming is the carbon dioxide, I think, that's releasing.
I am not actually sure on that
I
one.
think I looked into the material sheet, but we can add this later. But
Yeah, that'd be interesting.
there's something that's creating the foaming action, and the higher the
Yeah, yeah.
temperature, the more foaming you get.
And I think when you're hitting it with fire, you're actually closing the cells. So
Interesting.
you're getting more of a flatter surface, which is giving you that
Ah,
shine,
wow, that's cool.
right?
Yeah,
And then you can probably paint it a little bit easier or get a better surface finish than, that dull foam look,
porous. Yeah,
that porous look. Yeah, yeah, exactly.
yeah.
So that's an interesting material. More of there's some industrial applications, but it's more of an interesting side, and especially with like, more of these printers are now coming out with multiple materials, so now you can incorporate your soft materials with your hard materials, which is really
Yep,
fun.
yep. I know I had
And
done.
the shoes.
The shoe, I was just gonna say the shoes. Yeah. No, the shoes have been very interesting to watch people, and this is on social media that I'm seeing this, but people just printing TPU shoes, like Croc knockoffs or whatever. But yeah, it's interesting that people are just 3D printing shoes. Like I don't know how good they're gonna hold up or anything like
Hmm.
that. But those are mostly with like one durometer across the whole print.
The
Where something like this, when you think about what it could do for the shoe industry or
mhm,
the cosplay industry, and start, if you learn the material enough, you've prototyped with it, you've played with it, and you're setting up a job for production, like it was interesting with this. I had to do it very quickly. So I decided to print a very small version and test just like multiple temperatures to get a gauge on like what
yeah.
it was. Then I went a little bit bigger and then I printed the whole thing.
Hmm.
That is not I would not do that with a customer. But for me, totally fine because I needed to get it done in time for New York Comic Con.
And so, some of the shoes they actually are adjusting the temperature for the durometer
That's cool.
or adjusting like the walls or infill to adjust the softness too.
That the walls and the infill, I think, is this is the first time I've seen the material science version of
Hmm.
applying that, where usually, like you're saying, it's a setting based thing where like certain types of infills can give you more bounce. Like gyroid is more flexible than,
Yeah,
say, gyroid or something like that. No, not gyroid, cubic.
cubic.
Yeah. Or triangles or whatever else. Most of those are usually hard, which is good for some stuff, but not necessarily like a shoe, you know?
Yeah,
But yeah, we could totally dive into that a whole other day. But above that, you're kind of after the TPUs, and even in TPU, you're kind of in the exotic material. But past that, you're really in specialized area where
yeah.
you're only going to use that for a purpose because it's either extremely hard to deal with, expensive, or both.
And you're usually not on consumer grade printers.
No, no.
Uh,
Yeah, so then the expense of this material then just goes up like crazy because once you go into the industrial side of things, you're talking basically five figures or more for the hardware alone, and
yeah.
then if you're doing a spool for
It's
25
exponential
bucks,
with the
yeah,
cost of the printer and the cost of the materials.
yep, yep. That material goes from 25 for like a spool of 1 kilogram PLA. It goes up to 50 for half a kilogram, or sorry, 500. I mean, it just
I mean, yeah, I can go all
it
up to
it, it can
past
go
500.
it can go real crazy, and that's just the material.
Yeah, and
Yeah.
usually that material it's print a lot slower.
Uh-huh.
So even the print times and if you fail, you're sinking in so much more money
Yeah.
into the prototypes or the production parts.
100%. And so like that's where we've really honed our skills because we've had to deal with prototyping and building parts en masse with these more expensive materials. So like we've just felt the burn of those things
Yeah,
before.
and it's surprising the material science of it has gotten so much better. So most of these parts that are getting printed in Altem or Peak,
Mhm.
the very expensive materials are very specific. I'd say, 99% of parts that you might 3D print are perfectly fine with, I'd say the mid level of
Yeah.
engineering grade plastics, which I'd say almost all can be printed on some of these good consumer printers now, which is
Yeah,
crazy,
it is. It really is. Yeah, it makes you think about how much, and I think this is why we both have the businesses that we have, how much the industry and the people using 3D printers, how much learning there is still to be done, even on
Mhm.
something as seemingly obvious as like prototyping and not wanting to spend too much money. And but if you don't have any idea about this stuff and you just jump in or you get hired from a company and
Yeah,
they want the project to go, which is I think what happens most of the time, is people jump in, they get a 3D printer, and they want to go to the moon. They want to get this project done ASAP, and then that's where I think so much of the problem happens, where an operator comes in, starts working on this industrial printer, is working with this industrial material, and trying to do something that it's not necessarily made to do or
yeah,
needs prototyping, and that line between a prototype and a product is blurred, and then it gets real ugly when you've wasted a bunch of material and time. You don't have anything
yeah.
to
You know,
to show for it.
yeah.
That's where I think a lot of people get set back, especially companies trying to implement this in their own business.
No, it can take a lot of time and a lot of money to even try to prove the concept of the part or prove that hey, you can 3D print this, you can use this material. So there's
Hmm.
it can almost be a time and cost sunk and sometimes you never get anything out of it because it's just you don't
Yeah.
get to the stage with the customer where they're like, okay, yes, this is what we want, this is what we need.
Hmm.
Let's, go through with it.
Yeah.
So people will chase these clients, and a lot of them will get nowhere and just spend a lot. of money and time trying to acquire them.
Yeah. Trying to see here if there's anything else we can touch on. I think this has been great. I think we touched on so many good things about this and just the struggle of, and the art of going from a prototype to a production
Yeah. I mean,
model.
even like I think like you said about, just giving someone a 3D printer.
Mm,
Like I've even if you give, a person that's not a 3D printing person a 3D printer and give them the files that you've tested and saying, hey, you can mass produce this part with this
yeah.
file, with this printer, with this material, you'd think you'd get the same result as what you'd get, but you don't always. Like even just, how you utilize the printer, how you treat the printer, how do you
Yeah.
store the
How it was
materials.
manufactured, right? Printer to
There's
printer manufacturing. Like,
yeah, there's so many different the maintenance, the upkeep, how you handle the build plate, how you clean the build. Like there's so many different intricacies that you can't just hand someone the printer and the working file and expect the same results.
yeah, it would be great.
It would, yeah. You still
But
need, right? It comes to you still need, it's still a piece of equipment. You still need a trained technician.
yeah, yeah. Something we've both rubbed up against many times. Yeah. No, it's and this prototyping to production part is I think really important because so many people are looking to 3D printing to make a business or
Yeah,
to
it's an easy small upfront cost. It's
Mhm.
most people think it's easy to get into when you
Yeah.
get from prototype to production.
Hmm.
And, you know, with some of the new printers, Bamboo Lab and other stuff where you can print engineer grade materials at very upfront low costs, it's it's easy to get into, you know?
Yeah. Yeah. And if they stick into it long enough, they can really make something that's that's incredible. I mean, some of the stuff that I work with people on, even if it, you know, just bringing an idea into reality with 3D printing is something that's a joy of both of ours.
Hmm.
And this idea, like this is where the money is, as far as like the value, I should say, not the money. The value is understanding how to go through that and go from idea to final part. And that's a lot of what we talked about today, all the different areas that you need to consider
Yeah.
where things can kind of go off the rails. Yeah.
I mean, that's why most of my clients turn to me is exactly
Hmm.
for that. I can get you through that whole product development stage and get you parts afterwards, you know?
Yeah.
So,
And it gets more and more reliable, like the deeper that you go into it and invest into it. Yeah. But I think that's good for today, man.
yeah, it's a good
Yeah.
conversation.
All right. Tell everybody where they can find you.
Niche3D.io, Matthew Guy on LinkedIn.
Perfect. I am at ag3d-printing.com, ag3d printing on Instagram, and the ag3d Part Detective on LinkedIn. And you can check me out, Alex Orphanos, on LinkedIn as well. If you're looking for any kind of part success service, design, prototyping, production, you've got Niche,
Product development. Yeah.
product development, you've got Niche, you've got AG3D and the Part Detective. So reach out to us. And this has been Layered Insights. Finally have a name. That's it, folks. Thanks for joining us. Keep printing. Have a good one.